So we basically in chemistry today.
You did what with chemistry today?
E calculations and made it more complex.
Ooh, you probably did like having two things like interacting with each other, some shit, right?
Yeah, two things. Like I posted two questions.
Oh, nice, dude. Love that, dude. I love that gif I put that you tried to put the sticker on the forehead. It was too funny. Kids try to like give themselves bond coins. Like, no, you can't do that. Here, let me announce to the students. We're live. Come join the Twitch.
I think when I hit the $50.
Ooh, yeah. Which game do you want, dude? You're getting close.
I think Far Cry 6 would be good.
Yo, that just came out today, didn't it?
Something like
I saw
that.
some people streaming it. I was like, dude, I remember playing the OG Far Cry, dude. Way back, dude.
Yeah, so I thought that would be a good option.
That's a pretty cool game. Oh,
it's either that or get Call of Duty Vanguard.
Oh, Vanguard.
I'm never buying a Call of Duty in my life.
Yeah, especially when like it's free. You know, you're just like, why would I do this?
I learned my mistake.
Did you buy Cold War?
Dude, oh my god.
The Cold War was a mistake, dude.
I ordered that like the first minute.
No, don't buy Cold War, dude. I never bought Cold War. Someone actually gifted it to me. Is actually what happened. Someone gifted me Cold War, and I was like, this is the only way I'll play Cold War. Someone had to literally like give me a copy of Cold War, and then I was like, oh, okay, I guess I'll play it.
Alright, yeah.
Yo, what's up, dude? Who else in the channel here with us? What's up, dude?
Oh, Mango.
Mango! I heard Mango for a second, dude. Where is he?
Yeah, he's gone now.
Oh, okay. NFS No Limits Garage. What's up? Danny Yoshi, good to see you too, bro. Good to see you, dude. Alright, nice.
Alright, so basically the first question's literally asking if both pipes were 100 degrees Celsius.
Uh-huh.
One's copper and the other one's iron. That's what I was trying to say.
Two different materials here, dude. Alright, let's see it.
So, here, you need to rotate that.
I got it. Oh, let me stream on the Discord too. Sorry, I always forget that. They should have something that just automatically does that. Just automatically streams when I get in. What are we learning today, Danny Yoshi? Oh, we're learning some chemistry, dude. It's your lucky day, dude. Today we're learning chemistry. That's I did put that in the announcement. I said, let's learn some cool shit about math and science. This is chemistry.
On the top of the sheet, we got the iron and copper specific heat.
Okay, that's good to have. We do need that. We do need those things.
C equals for iron 0.45 joules over per gram degree Celsius.
Okay, so sorry.
For iron.
C for what? C for copper or for iron? Which one is this?
Iron. 0.45 joules over grams degrees Celsius.
0.45, okay. Joules per grams degrees Celsius. Okay.
Copper equals 0.38 joules over gram degree Celsius.
Joules per grams degree Celsius.
So
okay, cool.
If I'm not mistaken, it will take copper. It'll be faster and faster to raise heat and like raise in temperature and lower in temperature because it requires less energy. Correct.
For which one?
For number 3 is asking if both pipes
are left to cool in the same room. Which one will reach room temperature first? Yeah, which one would?
The copper, I'm pretty sure, because it requires less energy.
Correct. Yeah, because Q is equal to MC delta T. So they're at the same initial temperature, right? And they're both trying to get to the same final temperature. So this is the same, right? For the copper and the iron, right? Oh, I gotta hydrate. Thank you, No Limits, dude. Always forgetting to drink water, dude. I've never learned chemistry. Cool. I'm trying to learn here. Cool. All right, Danny Yoshi. So what we're doing here is this is kind of this is more thermodynamics. It's interesting that they put this into chemistry because this is kind of more of a physics thing, honestly. But what this is doing has to do with heat, which heat is the transfer of energy between objects. So what they have is they have two objects here. They have an object that is made out of copper, and then they have an object that is made out of iron, and they're asking which one takes longer to cool, or which one's going to cool down first, I guess. So the equation for that, right, as Philip said, Q, this is heat, is always equal to the mass times the specific heat times the change in density. This is a constant based on the material. Okay, first of all, are the pipes the same weight though?
Yeah. We're just assuming that.
We're assuming that? Okay, so we're gonna assume because honestly copper and iron have different densities, right? So if I had the same volume of iron and copper, would they have the same mass?
If I had the same volume.
If the same, let's say I had 10 feet of copper pipe and 10 feet of iron pipe, okay? Would they have the same mass?
No.
Why would they not have the same mass?
Well, actually, yeah, they would.
Okay, why do you think so?
Wait, because they're well. Oh, actually, wait. I don't know. Actually, that's a good question.
It's a good question, right? Yeah, okay. Because honestly, they say they're just 100-degree pipes, but I don't know. Like, are these like bong pipes? These crack pipes, dude? Like, what type of pipes are these? I'm assuming they're cooling pipes. Okay, so let's remember, right? So, if we have like a length of pipe, right, that's going to be equal to a volume of pipe, right? And the thing you have to remember, right, is that density is equal to what? What's the density of an object?
The equation.
It's an equation, yeah. But what is density equal to in terms of things? How do you measure how dense something is? Only plate tectonics. Cool.
Mass over
mass. Good. Yeah, mass over volume. Good. Okay. So do you see how I can rearrange this equation so that the mass of something is equal to the density times the volume? Okay. So if I have 10 feet of pipe, right, that's kind of like the volume, right? Volume is just a measure of like how much space something takes up, right? So 10 feet of pipe made out of copper and 10 feet of pipe made out of aluminum, or 10 feet of pipe made out of spaghetti, right? All of that has the same volume because it's the same amount of space that it takes up, right? So this is the same for the pipes. But, okay, I already said this, right? The density of the two metals is different, right? Copper and iron and spaghetti, which I guess is flour, they all have very different densities, right? So if you had these two pipes and they were both 10 feet long, would they have different masses?
Yes.
Yes, good. Yes. Because they have different densities, right? So if this was like the 10 feet of pipe, because this is different for copper and iron. What's up, mechanical dude? You feeling better, bro? He was in the hospital for food poisoning or something. This is different for copper and iron. That's going to be different, so this would also be different. Okay. But as you said, Philip, we're going to assume that
we have to. There's no other given.
Right, there's no other. Yeah, this is honestly because this is a shitty question, right? Because like, how do I assume it's the same mass of pipe? Like, pipe is not usually like sold by mass, right? Pipe is sold by volume. Like when you buy pipe, you're like, okay, I need 20 feet of pipe. Wow, dude, No Limit's making me hydrate so much. Okay, so mass is the same, right? Okay, so this is the only thing that's different, and you're right, Philip. So the one with the lower specific heat, that's what these C things
the lower
here.
amount of joules will be able to move more constantly because per gram and
well, we assume they have the same. We assume this is the same, right? This is the same. This is the same. So it's literally just coming down to joules. So what it comes down to is the copper needs less heat to leave in order for the temperature to drop the same amount that it does in the iron.
Yeah.
Right? And
yeah, that makes sense.
Okay, good, right? So, and heat, right? That's measured in joules. What do we usually measure? So, because this is interesting because they're saying like first, right? They're talking about time, right? So they're talking about what we would call like joules per second. Do you know what joules per second is measured as? Do you know what that is? Joules per second.
Joules per second?
Right. This is like, do you see how this is like a rate of heat, right? A rate of energy leaving.
So would it be watts, right?
Good, watts, right? Very good. This is watts, and watts is how we measure. What's the term? It's not velocity. It's not work. What do we measure it?
I don't know. Actually.
Starts with a P. It's a Kanye West song.
Power?
Yes. No man should have all that power. I just count the hours. Yeah. So power. So, we would assume that the rate at which heat is leaving is the same. That's what power is. Like, say for instance, you have an air conditioning unit. Have you ever seen that? Like, have you ever seen how they measure air conditioning units?
By wattage.
Well, they do by wattage,
Well,
but they
like more powerful.
yeah. So air conditioning units are measured in what they call BTUs. Have you heard of this before? BTUs.
What does that mean?
I know, the British thermal units is what it is. So BTU. British thermal. Like, so for instance, if I go here and I like try to find a portable air conditioner. Portable. Can I spell portable today? Jesus. Air conditioner. Okay. Do you see how this one says it's
BTU?
Yeah. Do you see how this says
BTU.
this says 8,000 BTU?
8,000.
8,000 BTU portable air conditioner, right?
Mm-hmm.
So this is a measure, and actually it's kind of funny because this number is actually bullshit. Because you see how here it says 9,100 BTU, ASHRAE, 6,000 SACC. It's because there are all these different organizations that like measure what the BTUs are on air conditioning units, and so depending like whose standard you're looking at depends on what the number is, right? Because some of them are like, oh well, I measure the amount of air conditioning power is this, and so this is always funny. If you're trying to like compare air conditioning units, like to see which one's more powerful, you have to make sure that the number and the organization that they use to measure it are the same, right? You can't compare 9,000 BTU this to another air conditioner that has like, I don't know, 8,000 of another industry, because you're just like, what? Do you notice this also on speakers, Philip? Have you ever noticed that like they'll say like 1,000 watts on the speakers or some shit, right?
Actually,
have you ever noticed that like when they sell speakers? So example of this would be
no, I didn't. I never knew that.
Okay, so if you buy speakers, what's an example of speakers? I don't know, Samsung outdoor speaker. Maybe this is a good one. Super loud portable speaker. Oh, this is it. This is a great one. Okay, cool. Because I remember looking at this at one point. See how this says 1,500 watts?
Yeah.
Wireless party speaker or something. Yeah. So this power rating is also kind of subjective, because there comes into what they call like how many watts RMS is it, how many watts peak is it, and how many watts like I think constant is what they say. Because music, right? Music is like bursty, right? There's like bits of loud and bit of soft, right?
Yeah.
Like music is like yeah. So in order to make that noise, that requires power, because you have to move a speaker. That's putting energy in a certain unit of time, right? So depending on like how like bursty or how like constantly loud your music is, will determine how much energy, how many watts the speaker needs to perform that. And so this number here that oh thanks, dude. Oh, what? Sweet. Did we get another follower, dude? We get another follower? Yeah, TT Hyper Javier. What's up, Hyper Javier? Good to see you, man. So this wattage here also is subjective, because sometimes, so whenever you're buying speakers and whatnot, you should look at whether they're calling this whether they call that RMS, peak, or continuous, I think is the other thing they call for it. Because a lot of times manufacturers will just try to like say whatever the bigger number is, because they know you'll buy it if it has a bigger number on it.
Yeah.
Yeah. But anyways, sorry, I got a little off topic here. British thermal units, BTU. Because that just reminds me of a lot of like marketing shit that they do all the time. BTUs is, what is it? Oh, it's a kilowatt hour. Oh, this is cool. Yes. Well, can I just get 1 BTU? 1 BTU to watt hour. Okay, 1 BTU is 0.293 watts. 0.293 watt hours is what they say. Okay, so 1 BTU equals 0.293 watt hours. Watt hours is what they say. Okay, so this is this BTU here. When they say, like, for instance, it's an 8,000 BTU air conditioner, right? That means that it can pull out 8,000 times 0.293 watts in 1 hour, which is this many joules, is what it is. So, what is this? 8,000 times 0.293. So that's 2,000 joules. 2,344 joules. So that's directly that's a measure of what you did here, Philip, where you're trying to see like how much heat, right, it takes to cool something down. Air conditioning units are literally measured with that. They will literally tell you how many joules it can pull out of a system or out of a room in an hour. And that's what they do. They do it like this. Okay. So here.
So we just copper is just
Yeah,
the
copper's the answer. Yeah, the long short
It took 15 minutes
yes.
to figure out, but
yeah, well, I already knew it was copper, but I wanted to explain the science along the way, you know.
Okay.
Yeah,
And
but
then
here,
I
let's
think
do number 4.
Shouldn't be too hard.
Okay, let's see it.
It's found that a 20.0 gram carbon rod releases 710 joules of heat energy when it cools from 80 degrees Celsius to 30 degrees Celsius. What is specific heat of carbon?
Cool.
So they're trying to ask for C.
Good, they're asking for C, right? So equation, right?
So 710 equals 20.0 times C parentheses and then start parentheses 30 minus 80.
C.
30.
Good. 30 minus 80.
And
and this 710 here needs to be negative. Whenever you're releasing heat, it's a negative Q.
Oh, okay.
Releasing heat is negative Q. Absorbing heat is positive Q.
Okay, so divide each side by 20. You get
like 35, 3.5.
35.5.
35.5. Okay, yeah. So.
And then divide negative 35.5.
Good.
And
equals
then
C
divide
times
each
minus
side
50.
by negative 50.
Good. There you go.
And then see what that equals to. You're gonna get 0.71.
Okay, that sounds about right. Units. What are the units on this?
Joules.
Joules.
Over per gram degree.
Per gram dot degree Celsius. Yeah, correct. Nice.
Wait, dot. Wait,
dot.
What's that dot for?
The dot means times. Is what it does.
Oh, okay.
Yeah, because it's.
I just thought my teacher put that dot for like degrees for like the Celsius, but on the other side.
Yeah, no. It means like grams times Celsius degrees, but yeah, they put a dot on it. What's up, Raiden, dude? Good to see you, bro. Nice. Hello, Raiden. How you doing? Cancer. Your audio does sound like cancer.
I got 5, 6, 7. Not bad.
Nice. Here. What happened to your internet?
Okay, hold up. Got another question.
You got another one? Yeah, throw it in, dude. Throw it in. Or is it just a
quick word question.
Word question.
It says calculate the amount of heat needed to change the temperature of 352 grams of water from 14.2 degrees Celsius to 29.6. So when it says grams of water, would that be my units to 4.18? For my specific.
Yeah. Because that's 4.186 is joules per gram per degree Celsius, right?
Yeah. So when it's asking 352 grams of water, it doesn't give me a specific number.
For what? For the specific heat of water?
It doesn't give me a specific heat.
The specific heat.
It wants water.
Yeah. Well, I mean, didn't they say it was water?
Yeah, it says 352 grams of water.
Then yeah. Water is assumed to be 4.186.
So this is gonna be easy then.
Yeah, you literally it's just plug and chug. Raiden, what's your question on cancer, dude? You can post it in the chat. I'll go through it. I'm not the expert oncologist, but I can use my science powers to figure out what you're trying to learn about cancer. For everyone else joining us on the stream, welcome. This is Office Hours. It's where I answer any questions you guys have in math or science. Kind of like just like a free tutoring hour, and we also reward you guys for participating, asking questions. You can find out more in the Discord. Just type !Discord in the chat. I'll put it in there. That has the Discord link where you can come see all the cool shit we're doing. What causes it, and how do you get rid of cancer? That's actually cool, Raiden. That's a cool thing actually. What causes cancer? I like that actually. What causes cancer? I actually kind of know this. May love Zach. What's up, dude? What causes cancer? Okay. So, Raiden, do you know what cancer is? That's a good question first. Do you know what cancer is?
Yo, live right now?
What's up, Grim? Yeah, we're talking about cancer.
Okay, wait.
Cancer
Let me get
sucks.
in.
Fuck
Let me
cancer.
get inside the screen.
Okay, get inside the stream, dude. Raiden,
I
you can
know I
you can
am,
you
but
can chat. You can text. You can text. That's fine. Just text. Just text me if you're eating. I'll be muted this because I'm eating. Good. Cancer are cells that are uncontrollably dividing. Yes, good. Correct. Right. So, your body is constantly producing more cells and losing cells. You know, an example of this is your skin cells, right? So, you ever notice like if you get a splinter or something, or you have like a cut or something, or something.
Blister.
Yeah, if you have something like under your skin, what's up, Tina, dude? Good to see you. Have you noticed that eventually, like as time goes on, whatever that thing is underneath your skin eventually just leaves, right? You don't see it anymore. Oh, gotta hydrate.
It does?
It does, yeah. Well, as long as it's not too deep, but
I gotta do dishes, so I'm gonna do dishes while watching the stream, okay?
okay, good for doing dishes. PMAT, yeah, was it? What is PMAT again? Prophase, metaphase, anaphase, telophase. Is that what it is? The phases of cell division, yeah. So your body is constantly losing cells, like skin cells, for instance. Like dead skin cells is literally what dust is, right? You guys ever see like dust all around the house? That's like skin cells on your body that are dying and then just leaving, right? So you need something to replace that. Otherwise, you turn into a skeleton. And the way that is replaced is that your body takes skin cells that are already there and they divide, so they multiply. Like one skin cell turns into two skin cells. And there's kind of like a programming built into this that tells your skin cells what rate to reproduce, what rate to split. And you're right, Raiden. The way that, for instance, cells become more cells, yeah, that is called mitosis. Okay, so mitosis is what causes the splitting of cells into more cells, splitting of cell into many cells. It's usually one splitting into two. That's what it is. Okay. So what can happen with cancer? So cancer is an uncontrolled growth, which means, however, that these cells that are splitting to like replace the ones in your body that are dying don't stop. Like they like lose the code inside of them to know like when to like put the brakes on and be like, yo, we don't need to like keep creating like a ton of cells like this quickly or whatnot, or let's wait for some more cells to die before we create more cells. So cancer is kind of like a bug in the genetic coding. It's like an unleashed dog. It is kind of like an unleashed dog, I guess. It's like a rabid dog. But yeah, what it is you just have a bunch of cells that just keep reproducing and they don't stop. That's why a lot of cancer is seen as, for instance, like a growth, right? You've probably heard this on like TV shows or something where they're like, oh man, he's got a growth on his liver like the size of a baseball or something, or he's got a cancer growth in his brain the size of a marble. That represents like cancer cells, which are just cells gone rogue that just keep reproducing and they don't die quick enough. So you may ask yourself like, so we could say that like the coding for when to stop splitting like fucks up. Okay, and there's a couple. So we understand cancer a little bit in that. I mean, there's a lot to understand about cancer. There's a lot we don't know about cancer, but what we do understand is there's this thing called free radicals. Have you guys ever heard of free radicals before?
Free radical?
Free radicals. Yeah, free radicals. Okay, cool. Have you guys ever heard of telomeres?
I don't know. I think I might know free radical.
Okay. So, okay, but you got...
Wait, free radical. Isn't it has to do with hold up. It has to do with the atom and it's not attached, right? To a bonding.
Oh, okay. Yeah, that's different. That's yeah, that's chemistry radicals. Yeah. I know what you're
Okay,
talking
because he talked about it and my teacher once mentioned that. It was something about like an unattached atom bond or something.
Yeah, that is a radical. Yeah, and I guess they are kind of similar in terms of cells, but okay. You guys know in for instance, in mitosis, right? That you have a point, right, where for instance, the DNA the DNA duplicates, right, the chromosomes, right, and you have like this thing.
Then how are we like if we're
Wait,
talking about how
mitosis.
cancer?
That seems really
If,
familiar. Hold up.
Yeah,
if cancer is when cells divide, then how are we supposed to find a cure for cancer?
I'll show you, bro. I'll show you guys.
Wait,
Okay.
hold on. Mitosis. That sounds too familiar.
Yeah,
for
dude,
me.
you guys
This
have
is
done
biology.
mitosis, dude. Like, come on, mitosis.
What is it? Can you explain it to me?
Yeah,
again?
that's
Just like a
fine. That's
refresher?
fine. So here, so this is mitosis. Mitosis is the way
Oh,
that
splitting of cells. Of
It's
course.
yeah.
I forgot about that.
Oh fuck. Let me clear the clipboard 1 sec.
Oh, I thought it was your toes, Gio.
Oh,
That sounds
stop!
really
It's not mitosis. What? God damn it!
good.
You gotta pay more bits for that.
Of course, dude. I just need refreshers and stuff.
It's okay. It's okay. So this is mitosis. So mitosis is what takes one cell and turns it into 2 cells, right? Okay. Do you see how like you have a bunch of genetic material, right? It duplicates or some shit, and then like they meet up right in the middle here, and then they split, right?
Your toes are very helpful.
Yeah, my toes are very helpful. But okay, audio died. Oh, it works now. Okay, good. I'm glad the audio works. So what happens?
Did you drink water yet?
What happens, guys, is that when these split or something, so these chromosomes, so here, these chromosomes are made of telomeres and another part. What is it? Yes, here we go. This is what I want to see. Can I paste it? Cool. Yeah. So guys, do you see how this shit right here, right? This is one of those things, okay? The DNA, this is a chromosome. The chromosome contains DNA, right? This is like
strands, yeah.
this is the genetic coding. Genetic coding, right?
I'm pretty sure I'm gonna have genetics in unit 2. I'm pretty sure I was supposed to have it by now, but stuff happened.
Dude, Bomby Boy, cancer is caused by being born between June 21st and July 22nd. That is true. That is true. It is caused by that. Is it June 21st?
They're gonna allow us to pick up our stuff tomorrow.
Oh, from school? That's good.
Yeah.
Okay, guys. So
I can finally check my girlfriend again.
this is the DNA. This is the genetic coding. This is what tells cells to stop reproducing at some point, right?
Stop having sex on the job.
Exactly. Stop banging each other on the job or something. Okay. And at the end of this DNA are these things called telomeres, okay? Now what happens is that if these things are damaged, these telomeres are damaged, then it fucks up the code. You know, have you ever had like a file or something and it's like it's corrupted or something and you can't open it or some shit?
Yeah.
Right.
Like if you were to delete System 32.
Good, exactly. If you were to delete System 32 or pagefile.sys, like, yeah, don't ever do that. If someone's like, like, hey man, you should code in your Windows folder and delete this file, don't do it. But yeah, so if the telomeres, they found with people with cancer cells that the telomeres are shortened, which means that the coding for your DNA, for your cells and whatnot is corrupt. And because of that, your cells then don't know how to stop reproducing, and so they just start going like fucking crazy, and that's why you get cancer.
Question.
Yeah.
Why are human bodies so fragile?
They're not fragile, dude. Actually, human bodies are amazingly resilient, dude. Do you see the homeless, dude? Like, they're still alive. Like, what? Like,
No,
I've seen people like...
You saw that video I sent in the counselor's office?
Which one?
You didn't see that video?
You post
Yeah.
lots of videos. Don't post any gore, please, in the Discord. Like, go to 4chan for that.
Yeah, that video right there.
Oh, wait, Dr. Go, I got a quick question.
Yeah, what's up, Philip?
Like a really quick one. So when you're doing joules, right?
Uh-huh.
If it's positive, is that heat released or heat absorbed?
It's heat released is negative.
Heat released
Yeah,
is
like
negative.
that.
Okay.
Positive heat is heat absorbed.
That video right there.
Okay.
That video is like if the human body would have been more resistant, like they wouldn't have died from that fall or something.
Oh, yeah. Well, I mean, eventually physics takes over, dude. Eventually, like, physics kills everything. Like, you can't survive. Yeah. Eventually, there's too much energy from, like, falling. But anyways, Raiden, so you asked, like, what cancer is. Cancer is damaged cells that just keep reproducing and they don't stop. And then you asked, how do we cure cancer, right? So this is a good question. So
You just stop those cells
One
from
way is
reproducing.
one way is chemotherapy.
good.
Right?
One way is chemo. So chemotherapy is how
Kill
to stop
cells, right?
cancer, how to cure. It's
Like,
funny
what
because
is chemotherapy?
okay, cure cancer. So chemotherapy is basically poisoning yourself.
Yeah, it's
Oh,
really dangerous.
Chemotherapy is
like
fucking
the
rough,
cells can't
dude.
reproduce?
Yeah,
No,
it's
it's
So the cells
really
can't
it's
yeah.
really bad.
Chemotherapy is so what you're doing is you're trying to kill all the cancer cells. The problem is it's hard to target what are cancer cells and what are not cancer cells. So chemotherapy kind of goes through this strategy of like, let's just try to kill fucking everything and hope that we kill more cancer cells than non-cancer cells. So it's almost like you're killing yourself, but you're not doing it all the way, hopefully, because tons of people die from chemotherapy. Honestly, one of my friends' good friends died from chemo, like trying to cure themselves from cancer. He was young, dude. The kid was like my age, like 21, 22 at the time. And
Oh my
My
god, he was
hockey
so
coach.
young.
he,
Oh my god, he
he,
was so young.
he was young. He had like leukemia or something, and or some rare cancer or something. So chemotherapy is basically you poisoning your own body and hoping that you poison it enough to kill the cancer cells, but not to kill all your good cells.
The only time I've actually been close to the brink of death is I'd say
Uh-huh.
like when I had appendicitis, like my appendix exploded
Oh shit.
inside me, and like the only reason I survived is it was inside me for like 4 days before it was discovered.
Oh, that's not
The
good.
only reason I survived is because a piece of poop clogged it up.
Okay, that's interesting.
I'm gonna go eat, Dr. Gold.
All right, good to see you, bro. Yeah, Raiden, you're right. Chemotherapy. This is why cancer patients go bald. Oh, that's cool. I didn't know it only attacks the fast reproducing cells. That would make sense, like, because that's what cancer cells are the fast reproducing cells, which your hair cells are, which are why patients go bald.
I
That's
mean, if
cool.
they're
I didn't know that.
damaged, if they're damaged, they don't have much to copy if they're damaged.
Yeah. Well, no, that's the problem. The problem is that like if the cells are damaged in a certain way, they produce too much because they don't know when to stop. So
Bro, you gotta learn when to stop.
yeah, I know you gotta learn when to stop.
So
So the other thing is radiation. So radiation is another type of treatment of cancer, and that's more targeted. That's where like they hit like a certain area of your body with radiation, and radiation will just wipe out the cells in that area.
They're gonna turn into Hulk soon.
Yeah. So radiation, I think, is easier on the body. Like you don't get like as sick. I think you definitely get sick with chemo because like you're literally like drinking poison. Like it sucks. Like it's not fun. But I think that's
Like,
that.
if radiation hits the wrong spot, doesn't it have a chance to kill you if it hits the wrong spot?
Yeah, of course. Yeah, radiation is not good. Radiation like just kills cells immediately. It really fucks up. Like, did you guys ever see Chernobyl?
I've seen Hulk.
Seen Hulk? Yeah. So that's an example where like radiation will actually change the DNA of cells.
Like mutate them.
It will mutate them, right? It'll cause them to mutate, right? With cancer,
Yeah.
you're hoping that you just mutate to kill them. But yeah, with the Hulk, right? He gets hit with radiation and then he can like grow like crazy or some shit. Yeah, that's an example of radiation changing the DNA for something else.
Yeah.
But yeah, okay. The new cures for cancer that are really cool. And my ex-girlfriend actually worked at a company that worked on this. It was called CAR T therapy. It's actually pretty cool. So what they do is they actually write new code to what we call like I think they're T killer cells or something, to identify cancer cells and attack them. Okay? So this is actually pretty cool. The company that does this is Kite Pharma does this. Kite Pharma T cells or something is what they do. Yeah, cell therapy. This is what they do. T cell therapy. Yeah, this is cool. This is what they do. So what they do is they get someone's blood and then they look at it and they find like the T cells. T cells are the cells that kill like bad cells. They're called T cells. And then they create a bunch of more of these cells. Like they recode these cells to specifically attack the cancer cells. like certain types of cancer cells, and then they put them back in the person's body, and then that CAR T cell knows to attack just the cancer cell through some cool shit here. It's very cool. So this is a very cool new way to fight cancer. It's very smart is what it is, because the other ways like chemotherapy and radiation are really just like Stone Age. Like we're just like trying to hit shit with like bats and rocks. Like we're just like, well, let's just kill everything and just hope that we just kill more cancer cells. This like you're creating custom cells that you're putting inside someone's body to kill just the cancer cells. It only works for certain types of cancer right now. It's also really fucking expensive. Do you guys know how much it costs for this therapy? Anybody got an idea in the chat? It's a good question of like how our medical system is built. Someone throw out a number. How much do you think this therapy costs?
Is it heartless to steal a cancer patient?
To steal a cancer patient? What do you mean? Why would you steal a cancer?
Sue a cancer patient for money.
Oh yeah, you should. Yeah, what? Cancer patients have it bad enough, dude. What's up, Raiden? You're saying something, dude. I'm waiting for you to say something, dude. You're in the chat. Yes, the T cells are hunter-killer drones. Yes, that's very cool. Yes, very good, Raiden. Yeah. So Raiden was saying radiation is like a nuke. That's right. It is like a nuke. You're just dropping it. You're killing fucking everything. And then the T cells are like hunter. Yeah, they're like specific little like assassins. They're like special forces. They go in and they just kill the cancer cells. Does it cost $2,700? You need a couple more zeros on that. So CAR T therapy, as it is right now, costs around $250,000.
That is, bro.
Yeah, so it costs.
That's like asking cancer patients to give up everything they have.
That's $250,000. Well, if it means you live or die, like, is your life worth $250,000? Like, probably, you know.
No.
No.
I'd rather have a good life before I die than waste all my money. I'd rather like than waste all my money on just like,
living
and end up being homeless.
But you'd be alive. You wouldn't be dead, dude. That's the whole point.
Yeah, but I'd be homeless.
You would be homeless.
Won't have any.
Yeah, but
and won't have any food.
It's okay. I'd take care of you, dude.
Okay, bet.
I got you, bro. Do you won't ever go homeless, dude?
You guys heard it here.
I'll take care of you.
You guys heard it here.
Don't worry. All right, Raiden, that's cool, dude. I like that question. That's a great question, open-ended question on cancer and stuff. If anybody else in the chat is like a biologist or like an oncologist or like knows more about cancer and stuff, please feel free to like reach out to me and like tell me if I was wrong with something. This is like what I know from teaching biology, and previous people I've known in my life who work with this. I would rather die peacefully than waste money and go through more pain. Yeah, well, you know. Yeah, I mean that's a whole thing. Euthanasia is a whole topic, but yeah, that's cancer. Cancer sucks. Fuck cancer. Anyways, cool. Anybody else have a question in math or science? Math, science, anything. It can be something open-ended. You do, Raiden? That's cool. What's your question, Raiden? Mitosis. Okay. What do you want to know about meiosis? Oh, like meiosis 1 and meiosis 2? Okay. That's pretty cool. Yeah, we can go over that. Are you in biology, Raiden? Are you in biology, dude? Oh, cool. All right. You're doing this then. Here's a cool little picture of it. Meiosis 1 and meiosis 2. Pretty cool. Okay. So,
question.
Yeah.
You know how cancer damage cells? And
Yes.
if you were to have like damaged cells like in your sperm, if like it was like a sperm,
yes. Like if someone gave you a bunch of radiation on your nuts.
Huh?
Like would it pass down to your kids?
Yeah.
Correct.
Would it pass down to your kids?
It would. Yeah, for sure. And this is actually where this comes into play right in here. So, meiosis. What meiosis? So this is called a diploid cell. Diploid. Have you guys heard about diploid and haploid cells?
No, because I'm barely in 9th grade.
All right. Well, you're gonna go through this at some point. So diploid cells means they have like two pairs. Diploid. I think this means like two. Double. So what you do is you start with a diploid cell here, which has double the pairs of chromosomes is what it is. 2n, good. Yeah, this is called 2n, right? Good. What meiosis 1 does is it copies this into 2 more diploid cells, right? So this is also 2n, and this is like 2n. Is what this is. 2n is 46, right? N is equal to 23. This is equal to the number of chromosomes. Okay. It does eventually. No. So promase. Yes, good. PMAT2, right, makes 4 cells that are different. So what happens is meiosis 1 makes a copy of what it does. It makes 2 of these daughter cells, which are also 2n, okay? These are complete whole cells, all right? Meiosis 2, which is another prophase, metaphase, anaphase, whatever, creates 4 just N cells is what it does. This is like 4 different. Yes, and these are called haploid, is what they are. And the reason it does this is because these cells are what we call our sex cells. So these are cells that combine, with the other sex cells from another gender, and that's how babies are made. Honestly, is literally how it's created. Yeah, gametes. Yeah, these are called gametes too. Is what they're called. Gametes is another way for it. Yeah, gametes. So if you ever want to make fun of someone, gametes is like. Mitosis are repair. Yeah, you know a lot, Raiden, dude. Raiden, you want to teach the class, dude? You know more than I know about fucking mitosis, man. Yes. Yeah. Mitosis are repair and cell growth. Meiosis is almost predominantly just for reproduction, right? Sperm and egg cells is what it is, yeah. Because sperm and egg cells are like half cells. Like, they can't really live on their own, really, per se. Unless they meet each other, right? That's the whole when a man meets a girl type thing, and that's how that is how you make more humans. Is you take the haploid cells from one gender and you mix them with the haploid cells from another gender, and then that creates a diploid cell, which is a whole cell of a new human being. Fun fact, Gold.
What are we talking about?
We're talking about sex, apparently, but it's meiosis is what we're talking about. He's like, oh, sick, dude.
No.
Wait, so I got a question.
What's up?
Can you change your genetics?
Yes. Can you change your genetics?
Yeah, so if you have XY, right?
Uh-huh.
Can you change it to XX?
Oh, no. No, you can't do that. You'd have to change.
Thank you.
You'd have to change every cell in your body, which would be impossible.
Thank you. That's all I need to know.
Right? Yeah. Oh, I mean, this goes into the whole how many genders are there and how many sexes are. I forget. I forget which one's the one. I think there are many genders but only 2 sexes. Is that what it is?
I think so.
You can identify with genders, but you can't. I mean, I don't know, dude. People just fucking just start yelling about shit. I'm just like, whatever.
I'm making up stuff.
I identify as a tree.
I'm a whale, though.
I'm a whale. Yeah. So, but you can change your genetics of your offspring, for instance. And so this is what they call gene therapy, for instance. There's something called gene therapy, which is pretty cool, where they'll go in and they'll literally change the different genetics of cells, and they do this by using what are called knockout. What are they? I think they're called knockout genes. Are they called knockout genes? Yeah, CRISPR. Yeah, knockout cells is what it is. Yeah, this is cool. Gene knockout. This is kind of cool. Yeah. They do this all the time with mice. It's pretty cool. Here, let's copy this image. There's something called knockout cells is what they use. So this would be a way, Philip, that you could, I think, again, I don't think you can change from XX to XY per se, because that would be an extreme knockout. But you can change, for instance, the genetic you can change what the offspring are, right? Because for instance, when you create, right, when you create a human, right, what you have, right, is you have a haploid sperm cell, right? and then you have a haploid egg, right? And then these two combine to form the first diploid cell, right? The first diploid cell. So for all these people yelling about abortions and whatnot, I guess like technically this would be the first like creation of life, but you know, whatever. If you edit the genetics of the gametes of the cells that are made from meiosis, the sperm cell and the egg cell, and if you modify that at the beginning, then you can change what the offspring is, because then the offspring, right, takes whatever this is, and it's going to start duplicating it like crazy, right? And that's how eventually you get, you know, happy human, right? And so what they do with knockout mice, which is pretty cool, is they look at, for instance, the egg cells. This is called the embryos, right? These are the egg cells of a mouse, and they'll insert a certain type of code or something, or some type of virus or something that will change what the chromosomes are on those embryos. And then when they go to create the mice by like inserting it into whatever, the mom or something, that mouse then does not have like that genetic that whatever that gene codes for, it doesn't have that expressed. So
I just had the weirdest thought. What if like, well, I just had the weirdest thought. What if like in like 10 or 20
Knockout
years in the
mice.
future, like actual education is actually like a high school or university or something?
Oh yeah, that would be cool. Like if I actually turn this into, well, there is like Khan Academy, right? There's like a real Khan Academy or something, right?
Yeah, like you just get people.
I just find like
work for
Khan
free.
Academy just kind of like boring, honestly. It's my whole thing. They kind of,
Yeah,
it's kind of like
that
meh.
would be awesome.
That would be
But
cool.
if that does happen,
It could, man, dude. It could.
You better make me a teacher.
You better well, you better be responsible like a teacher. Yeah,
I'm
I want to
always
know some stuff.
responsible.
What's up, Raiden, dude? What are you saying? What's your question? What's your question, Raiden, dude? We just went over knockout cells.
I
and
gotta
stuff.
go back outside. BRB.
Okay, nice, Philip. Philip got a bunk coin. Okay, cool. Yeah, you're good to see, bro.
5.5 thousand steps, sir.
Ooh, you're close to the 7, dude. Just got to go outside and run an additional. For those of you watching on the stream, we also give you rewards if you go out and exercise. If you go touch some grass, like that counts as
I don't know if I can do that extra credit thing tomorrow.
Oh, the Friday one? Yeah, the one that Catatonic's releasing?
I want to get that $50 gift card.
It's nice. Yeah, he's giving out a $50 gift card. If so you guys want to maybe go through what the example one was? It's kind of a fun one.
I don't know.
It was I think it was here, right? Oh, this is it with its solution, or he already gave the solution. Okay, first of all, what was D? I was actually kind of confused how to answer this, honestly, right? He gave me this. But what's he asking for? I'm confused.
He's asking for
Oh, they're asking for the degrees. They're asking for these degrees is what they're asking for. Okay,
if
cool.
that's going to be on the extra credit, then none of us are going to get it right.
Well, so what he's doing is here, and I can show you how it works. These are cool, man. So this used to, this is crossing over. Yes. Oh yeah, that's cool. Yeah, crossing over. You're right, Raiden. Yeah, crossing over. One sec. Crossing over is this shit happening, and what that does is that causes some parts of the red cell of the red chromosome to mix over with the white one. That's why you get genetic variation. That's why, like, for instance, when you're born, like, you know, your brother may have brown hair but you have black hair or something. But okay, here, let me cover this up. Cover up the solution. This is a good one, actually. It's actually cool. I think this comes from did you guys ever have math Olympiads or anything in school? Do you guys have math Olympiads? No. So math Olympiads was kind of like it was like the math competitions for us. It was like the Olympics. Yeah, nerd. Yeah, I am a nerd. What's up, Nick, dude? Good to see you, bro. Yeah, it's a math competition. Yeah, for sure. Yeah, it's a math. It's called Math Olympiads.
What's a math competition?
We're doing this now. Okay.
Oh,
I'm just showing how to do this one, so you guys can kind of get an example of how this works.
Oof.
Hold on. Let me see this.
Okay.
Because maybe this guys maybe this will give you a hint on how to do the next one when he puts it out on Friday.
I know.
I can't help you with it once he puts it out. Like so.
But if Actual Education does have a server instead of a a school, instead of a math competition, it would be a gaming competition or something.
Yeah.
Gaming school. Okay.
Anyways, okay. So this is cool. So Math Olympiads was like a little math competition where they would have you try to solve math questions as quick as you could, and no, Grim is fine. And then if you answered the most amount of questions, you would win for your team and stuff. It was kind of cool. It was like the Olympics for nerds. So anyways,
I'd say I'm pretty decent at math.
Well, good. Then see if you can do this, Uncle Bobby.
Oh yeah, I'm pretty good with numbers too.
All right.
Oh,
so they're asking you to figure out what the degrees are of this, right? This requires you guys to know trigonometry, right? Philip, you know trigonometry. Do you know
geometry.
So
do you know trigonometry?
basically, we're gonna find a
I know
degree, right?
geometry, not trig.
Okay, so here's what you guys need to know about trig.
We did intro to trig. Yeah, we did a little bit.
Have you guys ever done it? It's called SOHCAHTOA,
SOHCAHTOA.
right? This is sine is equal to
Sine,
opposite.
cosine, tangent.
Good. This is adjacent over hypotenuse, and this is opposite over adjacent. Okay. What SOHCAHTOA says is that the sine of an angle is equal to the opposite over the hypotenuse, as long as it's a right triangle. Okay.
So what we have is the hypotenuse.
So this is always the hypotenuse. This has to be a right angle. This is always the angle theta. This is the opposite, and this is the adjacent. Okay, cool. All right. So yes, you're trying to figure out what this is. So what they do first, which is pretty clever, is they break this up into two different shapes. Okay. So,
I'm not even muting my phone.
You're good. So you have two shapes here, right? So I believe. So they say square. This is important. They say square and right triangles. Okay. So if this thing right here is a square, right? What does that mean? The length of this is good. All four sides are equal. Good. So this side is also 2.05.
Oh, 2.05.
Right, because it says 2.05. This is 2.05, so this is 2.05. Okay. All right. Good. So we're trying to figure out this angle theta. So do you see how this is also a right angle?
Mm-hmm.
Right? Cool. So do you see that, for instance, the sine of this angle here would be equal to the opposite, right, which is 2.05, divided by the adjacent. The adjacent is this whole length here.
Mm-hmm.
Okay? But I don't know what that whole length is, right? I just know that whole length. So what we're going to do is we're going to call this part a variable. So what's a letter you guys want to come up with?
X.
X, cool. We can call that X. So this is equal to
F.
X F. Press F in the chat, guy, for respects. So right, this whole length here, right? The adjacent, that's sorry, it's opposite of hypotenuse. I fucked up here. Someone should stop me on that. The hypotenuse is this, right? This is just over the hypotenuse. Actually, we need a new thing for this. This is what we would call the hypotenuse, which we don't know, but we do know this and this. So actually, we wouldn't use sine. What trig function would I use, guys? Do you guys know?
Wait, which one are we gonna be using? The hypotenuse and the.
No, so I don't know what the hypotenuse is, but I kind of know what the adjacent is, and I definitely know what the opposite is.
Tangent.
Good, very good. Use tangent. So tangent of theta is going to equal the opposite over the adjacent, right? Which, it's funny, every time I say adjacent, I think
have a question.
I think adjacent. What's up,
Are
bro?
you gonna put this on your YouTube?
Yeah, I'll put this on YouTube. Yeah, all these things go on YouTube.
Okay, thank you.
Although I haven't uploaded the last 2 days because I've been.
Wait, what?
I know. Yeah, Twitch was having errors. No, I will try to upload it, but I was trying to download my Twitch streams the other day, and they kept like getting errored out. And I think that's probably because they got hacked. But this one should hopefully be on there. Anyways, opposite over adjacent, right? So the adjacent is x plus 2.05, right, guys? All right. So if I could figure out what x is, then I could figure out what theta is, right? Because this is an algebra equation. In algebra, right, if I have one unknown, I can figure it out. Here I have two unknowns. I don't know x and I don't know this, right? So I need more work. The whole rule in algebra actually is the number of things you don't know, you need that many number of equations. So how many things do I not know right now?
2.
2. So how many equations do I need?
2.
You need at least 2. Good. All right. So we need to come up with a second equation that involves x and theta. Okay. So let's see if there is another one. So then I kind of look at this shit, right? And I see that there's something else going on here. Okay. So let's look at what's happening here. So here I have, again, this is actually kind of tough, honestly. Let's see. And then I know this is up here, right? And then this has a distance. Yeah, right. So I know this is theta, right? I know this distance is x. I know this whole distance here, right? This whole distance is 2.05, right? Because the distance from here to here is 2.05, right?
Yep.
Oh, man. So, like... Oh, and I know this whole thing here, is 3.89. Oh. This is kind of cool, guys. See how I know this whole...
The hypotenuse, I told you.
That's the hypotenuse. Good. Okay, so what can I do? What can I do with this?
Get the hypotenuse and you have the length of it, so you're just going to be using sine, right?
So if I...
Your sine.
No, if I used, like, one of the functions, like sine or cosine or whatnot, I would have to be using this whole angle, right? Not just this part. Do you see that? Do you see, Philip, how this is the triangle now? Sorry, it's this. So it's no longer just this is theta, right? It's the whole thing.
So, I don't feel like doing this, to be honest.
No, you got to get this, dude. Come on.
Wait. So what do we have to do over there?
Well, so again, guys, right? I have 2 things I don't know. I don't know x. I don't know theta. So I create another shape over here. I look at this shape, right? This right here is what this is. Okay, this part of the triangle. I'm trying to have another equation that at least gets me x or theta.
Now I haven't been getting ads lately. If you're a subscriber, you get no ads.
Oh yeah, you don't get ads. Yeah.
Yes.
Yeah. Good job. So, all right. Do you guys remember the properties of a right triangle? What are some properties about the sides of a right triangle?
It's a 90-degree angle, right?
Good. It's a 90-degree angle. Ooh, come on, Philip. Do you see it?
So if it's a right triangle...
Starts with a P. Starts with a P. It's a PY.
Pythagorean Theorem.
Pythagorean Theorem. Yes, dude. Thank you, bro.
I should have known that.
Okay.
So C equals 3.89 and B equals 2.05.
Good.
Do the math. Square it.
Yes. So what he's saying, Pythagorean Theorem, guys, right? So one side squared plus the other side squared, 2.05 squared.
2.05 equals 3.
Equals the third side, 3.89 squared. Yes, good. You see?
My dude Philo got big tingling energy.
He's got big math energy. BME. He's got big math energy, dude.
2.05.
Good. Okay, so here.
4.20.
got in my note.
So here, can you get me x here, Philip? You can get x from this? See how there's only one thing you don't know, and you're trying to figure out x.
Yeah, can you write 4.20 under the 2.05?
Cool. Yeah.
No.
420.
And then 3.89.
Oh, I thought you guys were gonna do like
15.13 under the.
Cool. Good.
And then subtract.
Why don't you do like? Can't you do like reverse something where like you subtract one side?
That's what we're doing. We're subtracting 420 from each one.
And then you're gonna get 10.93.
10.93. Okay.
Equals 10.93.
So what does x equal?
You have to square root.
Square root it.
How do I do that on the phone?
You raise it to the 1/2 power. Right here, I can do it for you. I got a calculator.
Yeah, can you do it for me?
Okay, so that's 3.306. Okay.
6.
So now what am I going to do with this
You
x?
only do 2 decimals, right? So 3.31.
Oh, interesting. There's no sig figs in math, really. But
I know. I'm just saying.
You're right.
We
You're
had 2
right.
decimals the whole time, so
Yeah.
just keep it as 2.
Well, yeah. I mean, technically, for the number of sig figs, right? This is 4 sig figs. But I guess I only hit 3 here.
There's no sig fig.
Okay. All right. Fine. All right. We'll call it 3. I'm gonna call it 3-1. Okay.
All right. So now we have all the information we need.
Yeah. So what do we do with this?
We can do, what is it called? We can do SOHCAHTOA.
Good. We can take this x up here, and we can plug it into here.
And
right?
Yep.
So now I have tangent of theta.
Tangent 2.05 over 3.31
0.31.
plus 2.05.
Good, right? So now I get tangent of theta. So this is something you guys probably don't know yet. So I got to teach you this. So if I have 2.05 divided by second answer plus 2.05, this is going to end up equaling 0.3827.
3827, yes.
Okay, cool. All right, but I want theta. How do I get theta from this? So I have tangent of theta is equal this. Do you guys know what this inverse tangent is? Tan -1?
Oh, yeah. Oh.
Arctangent, yeah.
Do the inverse operation of
Good. You do tangent -1 of tangent of theta equals tangent -1 of this thing.
Yeah, I forgot about that.
Right? Don't forget, dude. Okay. Yeah, so guys, this is called an inverse. So what this does is tangent of -1 times tangent, these cancel. So this just becomes theta. But then you still need to do this, which you can do on your calculator. You can do
you need to do tan -1 and
of 0.3827. Good. And you get 20.94 degrees. And I think that's the answer. Is what that is.
What's tan equal to?
Tangent is opposite over Jason.
Yeah.
So let's see.
This is why math's being canceled.
Oh wait, it's kind of late.
Let me see.
I'm good with basic numbers. None of this advanced.
Ooh, Ghost. I can answer yours, Ghost Dog. I can do that real quick. But yeah, so the answer there is 20 point fuck, what is it? 20.94 degrees. Is that what the final answer was? Let's see over here. We can actually see it if I pull this. Let me pull it over here real quick. Yeah, see? 20.94 degrees. Cool?
Yeah, so if he expects us to know that, then nobody ain't doing it.
Well, that's why it's worth $50. It's worth $50, dude. It's worth $50.
Damn.
Wait, it's 3 people, right?
That question would have been worth $50 if someone got it right. That's huge.
Oh, so you had 3 chances. Okay.
Well, no, I think there's 3 different questions.
Yeah, so you get 3 chances.
Ghost Dog, I'll do this real quick.
I think I know
dude.
the answer to Ghost Dog's thing.
Do you? What do you think it is?
I'm gonna give it a rough guess, right? But I'm looking at it, right? So basically, you have to do 42 to the power of 1/3, right? So basically, you kind of gotta break the 42 into thirds, right? So 42 divided by 3 is 14, right?
Right.
And then you do 6 to the power of 1/3, and then you gotta break those into 3, which is 2. So then it becomes 7/2, and then 7/2 to the second power. 14/2 becomes 7, and then 7 to the second power is 49.
So wait, it's 42 to the 1/3 over 6 to the 1/3, right?
So then it becomes 14/2.
All
which
of this
then becomes
to the
7 if you
second.
simplify it, and then 7 to the second power is 49.
So yeah, here's an area. So if you have 2 numbers that are raised to the same power, you can write them as now this came in. Dude, Jesus, go away. You can write this as one number, like one fraction, all to the same power. Do you see that? Do you see how I did that, Ghost Dog? So instead of 42 to the 1/3 over 6 to the 1/3, I'm going to write that as 42 over 6 to the 1/3. Okay? What's 42 divided by 6?
6, 12, 18, 24, 32. 6,
math,
12, 18, 24, 30, 36, 42. So that's going to be 7.
Good, 7. So now you have 7
to the second power.
to the 1/3 to the 1/3 to
to the 1/3.
Well, because yeah,
I have no idea.
I haven't done to the 1/3 yet. I'm just doing the dividing here. Is what I'm doing.
Oh, okay.
Okay. All right, good. So now I have 7 to the 1/3 to the second. Okay. So here's the cool thing here, right? So anytime I have like a number to an exponent, that's the same thing as the number to the exponent times the exponent. Okay. So 7 to the 1/3 to the 2 would be equal to 7 to the what?
Say that one more time.
So anytime I have a number to an exponent to another exponent, like x to the a to the b, That's the same thing as x to the a times b.
Yeah. So you take the cube root of 7, and then you
square it. But okay, but so do you see how
but then
this?
you can't do it because it's not gonna be a perfect cube.
Right. But do you see how this would also become 7 to the 1/3 times 2, right? Or 7 to the 2/3. So I can either cube it and then square it, or I can square it and then cube it. The order doesn't matter, right? Do you see how this?
I think squaring it then cubing it.
Yeah, right. Like let's square it first. So you can rewrite the order of these with an exponent. So I can write this as 7 squared to the 1/3. So in that case, now I have 49 to the 1/3. So I need to know what times itself 3 times gets me 49. Which I don't think is a nice number. Am I tripping here? Like, this only breaks up into 7s. I think this is the simplest form of it. That's the simplest form of it. Or they would say, like, the cube root of 49. Is that?
49 would have given the more.
Yeah, that cube root of 49 that's the simplest you can write it as.
I mean, if we just started off with just doing it, multiplying both of them by the power of 1/3, we would have just gotten 49 as a whole number.
Well, 42 to the 1/3 means I need the cube root of 42, which I don't know what the cube root of 42 is. Nothing. You're right that 42 can be broken up into 3 and 14, which then can be broken up into 2 and a 7, but none of these are pairs. So like you can't pull any of this out. What I mean by pairs is, let's say we had the square root of 125. Do you guys know how to simplify this, the square root of 125?
5.
Okay, so you know it's 5 times what? This is the square root of 125.
15?
No, it's 5 and 25. 5, no, sorry.
Oh, yeah.
Sorry. It's not 5. Sorry, I'm fucking retarded. Sorry. It's 3. No, it is. It's 5 times 25.
5 times 25, which is 125.
Good.
Yeah.
Okay. And then I can break this into 5 and 5, right? Okay.
Mm-hmm.
Since this is a square root, I need to group it in pairs, right? So I can group the 5s here, and I can pull this out. So now this becomes 5 root 5. Yes, because this is what's left, right? If this was
kind of,
if this was the 3rd root, I need to group triplets, and that's why that would just become 5.
You would just have 5.
Yes, that's a cool trick for radicals and stuff. What's up, Mechanical?
I learned that earlier in the year.
What's up, Mechanical? What was your question?
I said his initial here. No, I don't think initial.
Is he?
All right, that's the end of office.
That is the end of office hours. That was pretty cool. Thanks for the question, Ghost Dog. You get a point. Okay, awesome, cool. End of office hours. Thank you all for joining and whatnot. I hope you guys learned something. That's the last office hours of the week. I'll announce tomorrow what game we're playing for the monthly tourney because voting ends. So if you haven't voted yet for what video game you guys want to compete in this month, go vote, please.
Finally finished the dishes.
Very good job. Good job, Grim, for finishing the dishes. That's great.
My feet hurt from standing up.
All right, you need to get one of those mats you can like stand on, which are like soft or some shit.
Are we gonna play Warzone today?
Oh shit! I don't know if I remembered to update. Is there an update out?
Well, let me check. I haven't updated mine either, so.
I think if the update came out, I might need to wait until tomorrow because that's like a 40 gig update, which I haven't downloaded yet.
Me too. Like this update did come out. I didn't update my
Yeah, I literally just booted my PC to stream. So maybe let's maybe play later tonight or tomorrow. Maybe I'll have some time tomorrow. I gotta if
I'm
there's
always on. You know I'm always on.
He's always down. But yeah, so that's the last office hours of this week. Guys, look out on tomorrow though because Catatonic's gonna post one of the $50 questions, which will be similar to here.
And I'm gonna try claiming all of them.
Yeah, you gotta do it. So I hope you guys paid attention and whatnot.
I want to get $150.
So you can fix your Xbox. You can, dude, if you get them all right. So you gotta try. No asking me for help. I'm not gonna let you guys cheat.
When I get an Xbox X, I can give it to my girlfriend so we can play together.
Oh, that's so nice of you, dude. Okay.
That's cute.
That's cute.
Okay.
No.
Anyways, thank you for joining the stream, watching whatnot. We'll be here next week, Monday, Tuesday, Wednesday, and Thursday. You can always use !schedule in the chat to see when we'll be on. Join the Discord if you want to learn more and get cool prizes. Otherwise, I will see you guys next week. Have a wonderful weekend. Peace.